Hello everyone, Jeff of the Green Review. Today we're talking about soil and water. Water is a chemical in the soil. It forms a continuous liquid link between plants and soil. Plant water uptake is created by leaf transpiration and the water pressure gradient difference in the roots. Water carries dissolved nutrients and plant produce chemicals in the soil solution. In a saturated soil, all of the pores are filled with water. There's no air in the pores. Gravitational water drains through the pores, allowing air to enter the soil. At the point when all of the gravitational water is gone, the soil is at field capacity. Water still in the soil is called capillary water, and it can still move around in the soil, carrying nutrients into plants. As the soil dries up, it eventually reaches the wilting point for each type of plant where they can no longer receive water. Water still clinging to the soil particles that's not available to the plants is called hygroscopic water. The sponge is still damp, but plants couldn't get any water out of it because it's clinging to the soil. The closer a soil is to the field capacity for the type of plants growing in it, the closer it is to the plant's thrive range. Soils at field capacity have plenty of air in the large pores and water in the small pores. The large pores of sandy soils allow too much gravitational water to escape for many plants. Clay soils have so few particles that they have very little capillary water for plants to use and a relatively large amount of unavailable hygroscopic water. What happens if there's not enough water? Dormant plants in the winter still need water in the buds, roots, and stems. If the plant is an evergreen, water is also needed in the leaves. Most of this water was absorbed into the plant in the fall. Because water movement is restricted in the winter, the buds, leaves, and stems might dry out and be damaged by winter winds and low humidity levels that can desiccate the plant. In the summer, cool season lawn grasses may go dormant and the leaves will turn brown. The crown of the plant is still alive though, and needs some water to stay alive. If dry conditions last longer than 2 weeks, a 1/4 inch of irrigation water can keep the grass plant crown alive without it breaking dormancy. Many plants have water-conserving tissue. It can be in leaves, roots, and stems. Plants from dry regions may have hairs on the leaves and stems to block sunlight and to keep the air humid between the hairs and the leaf surface. What happens if there's too much water? If a soil stays saturated for too long, the plant's roots can drown, causing a smaller root system that will lead to problems with the top of the plant. The top may begin to show signs of lack of water, such as wilting. If the plant and soil are not inspected, the wilted plant may be giving more water, which drowns more roots, and plants that drown are dead, and dead stuff decays, which may lead to disease organisms getting into the plant. Warm and wet climates accelerate the breakdown of organic matter in soil. So many soils in the southern United States have less organic matter than soils farther north where the climate is cooler. Southern soils are often brown or red and not black. The red color comes from iron that is left after many other chemicals and organic matter have been washed away. Where annual precipitation rates are high, water removes soluble chemicals, causing the soil to be more acidic. With less rain, chemicals such as calcium carbonate don't wash away, so soils in arid regions tend to be more alkaline. So what's this mean to me? Most landscape and vegetable garden plants prefer soil that's in the mesic range of having close to the field capacity. Shoreline and wetland plants thrive in soil closer to being saturated. Cacti and succulents need soil that drains closer to the wilting point of most other plants. place plants in the house or in the landscape in the proper soil to help them thrive. So what's this mean to me? Plants use water 24 hours a day. We don't have to water them 24 hours a day because the soil serves as a sponge to hold water for the plant roots. Each soil texture holds a different amount of water, and each climate supplies a different amount of water. In mesic and hydric climates, precipitation refills the soil sponge often enough that supplemental irrigation water is only necessary on an as-needed basis. In xeric climates, non-native landscape and garden plants may only survive with irrigation water, and rain is considered a supplement to the irrigation. And this is Jeff with the Green Review. Thanks for watching.